In this lecture, we introduce basic economic order quantity. The basic economic order quantity model, EOQ model, is used to find a fixed order quantity that will minimize the total annual inventory costs. How many units to order so we can minimize our total costs. The assumptions behind economic order quantity are only one product is involved. The annual demand requirements are known, and we know that demand is even throughout the year. The lead time does not vary. We're certain about the lead time, and each order is received in a single delivery, no partial deliveries, and there are no quantity discounts. We use example 6.1, Managing Business Process Flows textbook, in order to introduce this model. It's a healthcare institution with 9 hospitals, and each hospital orders IV kits independently. Their current inventory level or order size Q is 6,000 units per order. The weekly demand is 600 units. C is unit cost, or $3 per kit. Small letter H is physical holding cost, usually a percentage of the unit cost, and in this case it's about 5% of the unit cost. Small letter R is the annual cost of capital, 25%. Letter H, capital letter H, is the holding cost per unit. How much does it cost us to carry one unit for a period of time, generally 1 year? S is the fixed cost of ordering. In this case is $130 per order, no matter what the size of the order is. The lead time is 1 week. So how much should we order to minimize our total cost, then how often to order, and then the benefits of centralization. So if the ordering process is centralized. Now we look at the inventory cycle or inventory dynamics. If the horizontal line represents time and the vertical line represents our inventory level, in this case Q is 6,000, that's our starting point, and we have a usage rate, a constant usage rate of 600. When our inventory level reaches 600, considering we have 1 week of lead time, then we place an order. So 600 is our reorder point, and by the end of the 10th week, as about to deplete our inventory is replenished and the cycle begins again. So this is the read time. We place an order at 600, and the cycle continues, and this repeatable pattern is our inventory cycle. So from this point to that point is one inventory cycle, I cycle. The average inventory is Q, our starting inventory, divided by ending inventory. Our starting inventory plus our ending inventory divided by 2, or Q over 2. The current inventory level is 6,000 divided by 2, and our average inventory is 3,000 units. So the holding cost H consists of 2 parts, 2 components: physical holding cost, which is expressed usually as a percentage of unit cost, and the cost of capital. That's what would be the cost as the result of investing in inventory rather than investing in another opportunity loss. So the holding cost is the percentage of our physical cost times unit cost plus the percentage of the cost of the capital times the unit cost. So in this case is 90 cents, 0.09. The annual holding cost, so this is the cost per unit. The annual holding cost, sometimes referred to as carrying cost, is the average inventory times holding cost per unit. So Q over 2 is our average inventory. H is our holding cost per unit. If we substitute for these values, then the holding cost, the annual holding cost for this institution per hospital, per IV kit is 0.45 Q, 45 cents times Q, 0.45 Q. The annual holding cost, 0.45 Q, is a linear function, has a linear relationship with quantity. So if the horizontal line represents quantity and the vertical line represents our annual holding cost, we see it's a straight line, and it has a linear relationship. As the quantity is increased, the annual holding cost increases in a linear fashion.